You know, one of the powerful tools of Archicad is the ability to create 3D details. And today, I'm going to show you how to create a foundation detail for a house using complex profiles. Welcome back to the Colorblind Architect Does Archicad, and today just a very simple lesson on how you can use complex profiles as a means of creating three-dimensional details. Now, why would you want to do this? Well, to be quite honest, it's not necessary, but it can be a kind of cool feature. It can create some very interesting things. Like, for example, this is one that I and a colleague worked on together, and it turned out pretty nicely. It's in a historic district, so we had to do some historic elements to it, try to make it look a little bit more traditional. But on the flip side, it was also something that was quite fun because we got to throw in some modern elements and create something that was truly unique. Well, as we take the cut plane through, what I want to point out is the foundation. So as I orbit back, there we go. As I orbit back, you can see I've actually got a foundation footing along with a foundation drain and the gravel. I've also got the concrete wall with brick ledge along with the wood sill plates, the 2x sill plates, and also the 2x furring along with the insulation modeled in. Now obviously if I turned on the vector hatching, that would actually show up as a batt insulation in that 2x4 cavity, and along with the gypsum board. Now, how to do this? Well, let's get started. So what we're going to do now is we're going to get started trying to create a new complex profile. What we're going to do is we're going to go up here to the options menu, come on down to complex profiles, profile manager. We're going to select a new one right here, and we're just going to say concrete footing 1. Now, when we do that, the profile manager is going to open up. Inside the profile manager, you'll be able to zoom on in, and in complex profiles, if you haven't used them before, it's pretty simple. Within the profile manager, you can see a few options. First, there's this use with. This is the type of profile that you can actually use this with. So whether you're using this with walls, beams, columns, just regular library parts, objects, even railings, which if you watched my 3D site design video, you can see how I used a complex profile to create a custom railing to create a curb and gutter for a parking lot. So it's actually a very powerful tool. Now under here, then there's also design layers. Under this design layers, this one under construction is the one we want to focus on for right now. So coming over here to our different types of tools, we're going to select the fill tool. The fill tool normally is just a 2D element, but in a complex profile, we take this and extrude it. That's exactly what a complex profile. So imagine you're taking a section cut through the building, and whatever that section cut is, that filled area gets extruded out. It becomes linear across the face of the building. So in this case, let's start with a concrete. We're going to go concrete structural. And for my origin point, I'm going to make that the profile line of the complex profile. So in this case, I'm doing a continuous footing for a typical American residential project. Now, in other countries, you might use different foundation systems. Typically, a single-family home in the United States is going to have a continuous concrete footing with a concrete wall sitting atop of it for the foundation system. So we're going to go out 6 inches. And then I'm in a colder climate, so the footings have to actually go further down. And also the soils in my climate tend to be pretty poor. The Great Salt Lake Basin is actually in an area that's known to have high liquefaction danger. So the soils are all very soft and jiggly in an earthquake. So we typically have to put a bit bigger of footings than you might see in places like Tennessee or Virginia or California. So in this case, I'm going to go down 1 foot. And over here, I'm going to go out 2 feet. And then I'm going to go up the 1 foot. And I'm going to close it out. Now, typically our walls are going to be 8 inches thick, so I'm actually going to move this starting point over 2 inches so that that 8-inch wall will actually align with it. Now, another thing that is common is sometimes there's a keyed joint in a concrete foundation. To do that, you might just draw that in. For the purposes of this lesson, I'm not going to worry about that just because that overcomplicates things. So the next thing I'm going to do is I'm going to go ahead and draw the concrete foundation wall up above it. I'm going to go ahead and set my width as 8 feet and the height as 4 feet, just so that we have something to work off of. Now, in a colder climate, a lot of times you'll have basements, so I would actually want to make this another 4 feet taller at 8 feet. Now, the reason why I want to do that is, so a typical basement is going to be 8 feet. Sometimes people pay extra, get the 9-foot basements, sometimes 10-foot basements, but 8 foot's the most common. Now, above that, we need to have a wood plate sill for the wood framing of the house to rest upon. Usually this is a single plate, so we're going to grab another fill tool, and this time we're going to select structural wood or wood frame lumber. I'm going to zoom in just a little bit so I can see it better. And as you can see on my pet palette, there's an indication of the dimensions. I'm going to hit the D button so that I can adjust these. And for the height, I'm going to set it at 1.5 inches, which is the actual true dimension for a 2x4 thickness. And I said 2x4. It's actually a 2x6 typically for a sill plate. And that's our 2x6 sill plate. Now then what I'm going to do is I'm going to Command D or Control D so that I can do a drag. You can also go to the Edit, Move, Drag. But what we're going to do is we're going to drag a copy. So while it's in the drag command, if you're on a Mac, you can hit the Option button and then click in the same place. That way we actually have 2 copies of this. So now I'm going to select the node, make sure it's actually set to the node, and drag that. Now I'm going to do the same thing on this one. Actually, I'm going to delete that off. And now I'm going to drag a copy. I'm going to hover over it, and as you hover over it, you'll see the midpoint showing up. Now, if you don't see the midpoint showing up, and by the way, you can also turn off the line thicknesses if it helps you see a little bit better. In this case, it will help. If you don't see the midpoint, remember up here on your snap guides, you can actually set your snap guides to whether they're half or divisions or percentage. In my case, I'm using half right now, but sometimes you need thirds. And if you need to adjust that, you can also come down here to set snap point values, and you can adjust how many divisions or what percent or what distance you want. It's a very handy tool when you're drafting in Archicad, and I highly recommend you get to know these basic tools. That would be a different tutorial than this one, though. This is a little bit more of a complex lesson. So now we're just going to mirror about the midpoint for this piece of wood and mirror about this piece. Now the reason why I've done this is because typically in a 3D section or in a 2D section, a continuous lumber piece is going to have an X going through it. Now if it was blocking, it's just going to have a single diagonal line. Now these are American conventions. If you're in a different country, you might have a different convention, but the reason for doing this is so that in 3 dimensions, these lines will show up. So while we're at it, I'm just going to hit save just so we don't lose progress. Now, our next thing is I want to put in a foundation drain. Now, surprisingly enough, in Salt Lake City, this is, although it's a desert, it is in a lake bed. As I mentioned, we have high liquefaction danger in earthquakes. The soils tend to have really high groundwater. In fact, the groundwater is often as high as 3 to 5 feet below the surface. So you'd be surprised at how much water there is in a desert. But in this case, because of that, anytime we have a basement, which is actually quite common because of how cold the winters are here, it does make sense to have a deep foundation. Thus, it makes sense to have a basement. So what we're going to do here is I'm going to take the circle tool and I'm going to go ahead and draw a 4-inch diameter circle. So obviously it uses the radius for selecting that. And as I do that, you'll see the little arc coming out. We're just going to close it right here at the end point so that we get a circle. Now the next thing I'm going to do is I'm going to go ahead and take this fill tool, and before I actually do the foundation gravel chimney, I'm going to create a protection board. Now the protection board can often be insulation. Sometimes if you don't have the insulation on the outside, it can be just a piece of lumber. A lot of times in this environment we do go ahead and just put insulation. Sometimes it's even just protection, like putting up a bituminous coating on the foundation. It just depends on the design and especially the geotechnical soils report that you get on the recommendations on how to handle the footings. So that's the only reason why I point out that these details may vary based on your climate and your specific site soils condition. But in this case, what I'm going to do is I'm going to go ahead and choose the insulation foam board, and I'm going to go ahead and draw in this protection board. And instead of going the full 8 feet up, I'm actually going to keep it back about 8 inches, so 7 feet 4 tall. And for the width, I'm going to make this 2 inches. And the reason for that is you need to have soil over top of this, so you don't really want to have it go all the way up. But at the same time, if you are going to use outboard insulation, technically in the code you're supposed to have it go all the way up. It's one of the areas that's really tricky with outboard insulation, but that's a subject for another day. Let's go on to the gravel. So I'm going to go ahead and grab a gravel fill, and we're going to use the polyline tool. And by the way, you can also adjust your line types for the borders of these filled regions and also what contour pin. And I'm just going to make this a little bit goofy. And the reason for it is a gravel chimney is basically up against soil. It's not actually going to have straight lines. So a lot of times I like to just draw it in a little bit wiggly so it's clear that it's more of a natural finish. And then in this case, I'm just going to go ahead and draw it all the way up to the top of the footing, assuming that there's going to be a concrete slab for the basement right over top of this. And let's close this off. And obviously, if I'm getting things horribly wrong, go ahead, put it in the chat. I'd love to hear your thoughts on how to do a foundation drain. There's a lot of different ways I've seen it done, so I would love to hear different ways of doing it. This is just one of the ways that I've seen done many times around here. And I'm going to change that to gravel just because I want to see the actual circles indicating the gravel in that fill. All right, my next thing is to create the foundation drain. Now the foundation drain is typically a perforated pipe that as the water comes up to this foundation wall, it's going to flow down this gravel chimney. Because the gravel chimney, it doesn't have the soil in it, so the water is going to flow a bit more free. And water, it's going to go the easiest path out. Well, what's easier than an open pipe? Well, the perforated pipe basically creates a conduit for basically the foundation drain because it's perforated, but it allows that water in. But because it's an easier path, the water will tend to flow through it. And then this gets connected to another pipe that can then convey it to another area of the lot or even into a stormwater system. Just depends on your local area and the proper design methods that you should be using for your particular local jurisdiction. So in this case, I'm going to do this as a filled region, and we're going to set it as airspace because it is pretty much empty airspace. And I'm also going to change my pen type to a thicker pen type. In this case, 148, because for this particular pen table, that gets you a 0.8 millimeter line, solid black. I want this one to read very clear against the hatch pattern of the gravel. Now, because we've already drawn the circle, now we can use the magic wand tool. What we're going to do for the magic wand tool is we're going to hold the space bar. You can see the magic wand showing up. And we're going to hover over the circle so that the fill region will follow the circle. Now we've got a filled region that's airspace, and it will be circular in shape. Now let's turn the line weights back on. And now you can see we've got a foundation footing, foundation wall, a sill plate, a gravel chimney, the protection board, insulation, and a foundation drain. And actually what I usually do for the floor is underneath the concrete slab for the basement, I'll also include about a 4 to 6 inch layer of compacted gravel fill. So I'm just going to lower this by 4 inches because my intent is to use just a regular slab for the floor, and this will actually just act as a wall. So now I'm going to hit save, and as we go back to the 3D view, what I want to make clear here is I'm about to change this up, but this is not the actual correct type for this particular model. And this is actually an older project, so it doesn't really matter. It's already built. The homeowners are happy, but I'm going to go ahead and take out this footing element. And now I'm going to take this wall here, and I'm going to go ahead and, since it's already drawn, it's already set to a complex profile. I'm going to just go ahead and change the complex profile to the concrete footing that we just drew. And you'll see what happens when we do that. It's going to be different than what we drew because it's going to be mirrored the wrong way. So as you can see, the gravel chimney's showing the wrong way. So now what we're going to do is we're just going to drag that, make sure it's highlighted yellow so it's locked into the X axis. I'm going to drag it over the 8 inches. And now I'm going to hit P to mirror it about the reference line, this blue line in 3D. And getting lots of errors, so that's fun. Now, you'll see that the pipe is not showing up because what I forgot to do was to subtract that pipe out of the filled region. So let's go back to that, and let's go ahead and select the gravel chimney, then select the fill tool, and now we're going to hover over the circle with the magic wand, click again, and that will delete out that circle area from this gravel area. We're going to hit save, and then go back to the 3D view, and you can see the pipe will now reveal itself. With errors. Now, if I had slightly more time, if I really wanted to get more into this, I could actually add the pipe material as a filled region. I could also add in the furred-in wall like what we have on the prior. There's a lot of different details that you can add to this. Obviously, in this model, you can see that I even modeled in the exterior walls with the sill plates and the top plates. I put in the rim joists. I put in the TJIs. So I went to town with this model, but you don't necessarily have to do that. Now, the next step that's very important. Now, I'm going to go ahead and turn off the connections just so that you can see what I'm about to say. So you can see that by deleting the connections that I had already created, the soil is actually going through this wall. So what we're going to do is we're going to select both of these mesh areas, and we're going to go ahead and click on this icon here, the solid element operations. Solid element operations, if you do not use these, you are crazy. These are the bomb. They are awesome. So make sure your meshes are selected as the target, and now select the wall, add it as an operator, and make sure that the operation is set to subtraction. Now you can, if you want, choose subtraction with upward extrusion, which is what I've used for the floor slab, or subtraction with downward extrusion. Sometimes that helps. And if you watched my 3D site tutorial, intersection, that's a very helpful one too. Addition, I don't use that one very often, but it is also helpful in the right circumstances. In this particular instance, we want subtraction. Click execute. And once it does the processing, you can see, voila, we have our foundation wall subtracted out. Now, I will tell you what I don't do for this methodology. I do not usually do the foundation wall and the footing as a single element. The reason why is I like to be able to show on the basement floor plan the foundation wall as a separate element. So what I'll usually do, and what I did on this particular model, is I had the foundation footing as a separate complex profile, along with the foundation drain and the gravel, separate from the actual stem wall that goes up and supports the house. The reason for that, like I said, so that it shows up on the basement floor plan without the footing showing up. And then I can have the basement footing on a separate layer that can show up on a foundation plan for the structural. You would even want to go a step further. I would even separate out
the footing from the foundation drain, the chimney, and all that as yet a separate complex profile. But what you can do is when you go into that complex profile editor, you can actually draw it up like you would do in a typical 2D section. But then you can duplicate these using the duplicate command for the profile manager, and then delete out the parts of the complex profile that you do not want. It's a great tool, and this is not the only area where you can use this tool. I've used complex profiles for 3D details, and I do have to give my props out to Tim Ball out of the UK. He is the one that I learned this from through Eric Bobro's master classes, so credit goes to him.
So again, like I said, props go out to Tim Ball for showing this technique to me through Eric Bobro. Eric Bobro's been doing a great job with this for decades, teaching people how to use Archicad. If you don't use Eric Bobro's tutorials, you are missing out. He has some fantastic tutorials, and go ahead and pay for some of his master classes. It's well worth it. I've learned so much from him, so I just want to put that out there. I'm doing these for free just because I want to help people, but if you really want to dive deep into really good quality Archicad usage, go ahead and pay for Eric Bobro's classes. And with that, I'm just going to say, have fun, learn, and improve your skills. It's so much fun to be able to do this, and especially when you can show these models to your clients and it's got everything already in it, and they can see where all the joists are and the fully modeled stairs. It shows them not only what it's going to look like, but it also shows them what the crap you're doing, which is important. As an architect, you need to instill confidence in your client. Now, obviously, if you don't know what you're doing, learn. Don't just try to BS your way through things. Actually try to learn. Try to be honest about it. But hopefully this has been a helpful lesson. I'm the colorblind architect doing Archicad. Peace out.